Today, modern industrial automation operates at an unprecedented scale and blistering speed that completely defies traditional manual intervention. But for decades, building these systems hit a hard bottleneck in the engineering phase. Engineers were forced to rely on siloed tool chains. To make a single machine run, you program the programmable logic controllers in one software environment, design the human-machine interfaces in another, and configure the physical motor drives in a third. Connecting these isolated workstations requires a tangled web of manual cross-referencing. If a mechanical requirement changes, a single variable update demands tedious manual tag revisions. When engineers miss one tag, synchronization errors cascade through the network. To eliminate this fragmentation, Siemens developed the TIA Portal, collapsing these separate workstations into one central hub. TIA Portal uses a shared data architecture to link these previously isolated engineering tasks. Consolidating hardware configuration and logic into one project database creates a synchronized foundation, allowing engineers to manage complex production lines without the manual overhead of traditional tools. At the core is the centralized project database. Engineers plug in Step 7 for PLC logic, WinCC for graphical interfaces, and Startdrive for precise motion control. Because these share a central database, a data tag created once is instantly available everywhere. This systemic data inheritance means an engineer only declares a variable once. There is no duplicate tag mapping to manage, which minimizes code discrepancies across the system. The same architecture applies to safety protocols. Through the Safety Integrated feature, fail-safes and emergency logic are embedded directly into the central automation process, rather than bolted on later. Replacing repetitive manual data entry with scalable modular intelligence accelerates initial deployment and simplifies long-term maintenance. Modern project timelines rarely afford engineers the luxury of waiting for one phase to finish before starting the next. Traditionally, development followed a rigid, sequential path. Hardware configuration had to finish before logic programming began, bottlenecking HMI design. But a unified database enables multi-user engineering. Now, hardware, logic, and interface teams collaborate simultaneously on the exact same project file. Teams accelerate this parallel development by utilizing centralized project libraries. Engineers pull pre-tested, standardized code blocks and drop them directly into their concurrent workflows. Eventually, this concurrent software development must interface with physical machinery, a critical transition phase known as commissioning. Rather than testing new code on live machinery, engineers use PLCSIM to perform virtual commissioning. They use this platform to fully validate complex PLC logic against a highly accurate dynamic digital model of the entire factory floor. Running the automation logic through this digital pre-validation identifies timing errors and code faults that would otherwise cause catastrophic physical collisions on the factory floor. Moving the bulk of system testing from the physical floor to a virtual environment reduces deployment errors and keeps real-world downtime to an absolute minimum. Zooming out from a single machine, entire facilities face a structural integration gap, connecting deterministic hardware on the floor to high-level IT infrastructure. The foundation is the operational technology, or OT layer, containing physical SIMATIC PLCs and dynamics drives. These rely on field-level protocols like PROFINET to exchange high-speed data. Above this sits the information technology layer, where enterprise analytics, edge computing, and cloud platforms live. The challenge lies in translating machine data into formats that cloud algorithms can process. TIA Portal acts as the translation hub, bridging this gap. By supporting protocols like OPC-UA and industrial IoT directly within the engineering environment, the platform standardizes data exchange and securely routes it across the enterprise network. Acting as the bidirectional bridge between factory hardware and cloud analytics, this architecture provides the engine for true IT and OT convergence. In sectors like pharmaceutical production, maintaining this unbroken data continuity is required for regulatory compliance and batch precision. But leveraging a unified platform requires discipline. Teams must replace ad hoc coding habits with rigorous, standardized project management. To manage large projects effectively, developers rely on specific directives, standardizing library organization, enforcing modular programming, and configuring robust cybersecurity. Enforcing strict library organization ensures that code remains decipherable and scalable, even when handled by multiple global teams over a span of decades. This level of operational clarity prepares facilities for the transition toward Industry 5.0, where machine precision integrates with human-centric oversight. Looking ahead, future updates to the platform are increasingly focused on AI-assisted engineering and the integration of edge-deployed artificial intelligence. Embedding industrial AI directly into the control architecture enables real-time predictive maintenance, driving the evolution toward fully autonomous manufacturing. Siemens TIA Portal redefines automation engineering, shifting the focus from manually connecting disparate systems to managing a factory's logic and data through a single synchronized source.